We will continue with our introduction to coordinate geometry, and now we're going to look at the distance between 2 points. So we're interested in looking at a question like question 3 here. Find the distance between each of the following pairs of points. So if we just start off with part 1 here, we have the point 2, 3 and the point 5, 7. And we want to find the distance between the point 2, 3 and the point 5, 7. So we want to find this distance here. Now the idea is what we're actually technically doing is looking at this in terms of a right angle triangle. You've got a horizontal distance and a vertical distance, and the distance between the 2 points is actually the hypotenuse of this right angle triangle. So what we're really doing is using a bit of Pythagoras theorem to figure out the distance between the 2 points. And the good news is we have a formula that can take care of this for us. If we have any point A, which we can call x1, y1, and any point B, which we can call x2, y2, and we want to calculate this distance, well, we can use the distance formula that tells us the distance from A to B is the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. And this formula here is really just a version of Pythagoras theorem for the coordinate plane. So let's take a look at this example here. We have the point 2, 3 and we have the point 5, 7, and we're going to use this formula in order to calculate the distance between these 2 points. Right, so the first thing we need to do is label our points. So I label the first point x1, y1, and I label the second point x2, y2. And I want to get the distance between those 2 points. So we'll fill into our formula that we have here. So the distance from the points A to B, if we label the first point A and the second point B, is the square root of x2 minus x1 to be squared. So that will be 5 minus 2 to be squared, plus y2 minus y1 to be squared, 7 minus 3 to be squared. And then the rest of it, once you've filled in, is just calculating it. So the distance from the 2 points will be the square root. So 5 take 2, that's 3 to be squared, plus 7 take 3, that's 4 to be squared. So the distance between the 2 points is the square root of 9 plus 16. So the distance between the 2 points is the square root of 25, which is equals to 5. So the distance between the 2 points is 5 units. So this distance from the point 2, 3 to the point 5, 7 is 5 units. Let's have a look at one more example here. So I'll go through this part 4 here from the point minus 5, 3 and the point minus 1, minus 3. So we have the point minus 5, 3 and minus 1, minus 3, and we want to get the distance between these 2 points. So once again, we're going to use the same formula, and as I've already said, the formula is really just a version of Pythagoras theorem. So we have our points minus 5, 3 and minus 1, minus 3, and remember we label the first point x1, y1 and the second point x2, y2, and then it's just a case of filling into the formula. So this time I'm going to say the distance, capital D for the distance, is the square root of x2 minus x1 to be squared. So that's minus 1 minus 5 to be squared, plus y2 minus y1 to be squared. So that's going to be minus 3 to be squared. So the distance is the square root. So I'm going to deal with this minus first. So I've got minus 1, now minus plus 5 to be squared, plus then minus 3, that's minus 6 to be squared. So continuing on here, the distance is the square root of 4 squared plus minus 6 squared. So the distance is the square root of 16 plus 36. So the distance is the square root of 52, and you can leave it in this format generally as root 52 because that can't be simplified to an integer value, but sometimes you might like to type this into your calculator and you will see that the square root of 52 is 7.211 units. So as you can see here, the distance between the point -5,3 and -1, -3, this distance here is 7.211 units, or root 52 units. So that is the introduction to the distance formula. The best thing for you guys to do now would be to practice some of these questions, check your solutions online, and for access to questions, solutions, graded quizzes and more, visit www.limbymaths.com.